supposed to write each equation in logarithmic form. So the first one's going to be log base 2 of 32 equals 5. Second one's going to be log base 5 of 1 divided by 125 equals negative 3. And the third one is log base 6 of 216 equals negative 3. Let me color code these for viewing pleasure. So you might want to pause this video and check out that if you did not understand it. Number 4, write each equation in exponential form. It's the opposite of what we just did. Number 4 is going to be 3 cubed equals 27. 5 is going to be 4 squared is 16. And 6 is going to be 10 to the negative 2 is 1/100. Also, if I color code this for your viewing pleasure, you will see the following pattern. Evaluate each expression. Number 7 is simply log identity number 1. Log base 7 of 7 to the third equals 3. That identity just says that if your logarithm's base and your argument's base are the same, the answer is the exponent for the argument. Number 8, we could rewrite 1/1000 as 1 divided by 1,000. We could then write 1/1000 as 10 to the negative 4. Using the same log identity number 1 we did for number 7, we get negative 4. Number 9 is log identity number 2. A base of 3 has an exponent that is a logarithm that also has a base of 3. So the answer is just the argument, which is 6. Number 10, that same identity once again is negative 4. Number 11, if there's no exponent for the argument, it means it's a 1. So this answer is simply a 1 for the same reason as 10. Number 12 is not quite as simple. The exponent has a coefficient. That coefficient needs moved. Move it as an exponent for the argument. Simplify that, you're going to get 3 to the log base 3 of 256. Using log identity number 2, that makes this just 256. Solve each equation. If I write number 13 in exponential form, I get x cubed is 64. 64 is the same as 4 cubed. Therefore, x is 4. Number 14, log base 4 of 0.25. I can write 0.25 as 25/100. 25/100 reduces to 1/4. 1/4 can be written as 4 to the negative 1, which makes this problem negative 1. Number 15, property of equality. If I have only 2 logarithms, one on each side of the equation, they have the same base, and there are no coefficients, I can simply write it as the argument on the left equals the argument on the right. Solving the equation by conventional means will give us x is 17 divided by 2. Number 16 has a square root. Perhaps if we wrote that as 10 to the negative half, makes this more obvious. Log identity number 1, once again, makes this 1/2. Number 17, if you write this in exponential form, you get x squared is 49. Square root both sides, you get x is plus or minus 7. Recall that our base is supposed to be positive. That's in our definition. So that means x is positive 7. It's not plus or minus. 18, property of equality once again is going to make this 4x plus 4 equals 64. Solving this equation by subtracting 4 then dividing by 4, we're going to get x is 15. Number 19, if we use the property that allows us to change this to exponential form, we get x to the negative 4 is 16. 16 is the same as 2 to the 4th. Notice the exponents are almost the same. One's negative and one's positive. To change the exponent on the right to be negative, just reciprocate the base. So instead of a 2, it's a 1/2. Since the exponents are the same, that means the bases have to be the same as well, so you get x is 1/2. Number 20, if you change the cubed root of 10 to 10 to the 1/3, then use log identity number 1, and you're going to get x is a third. We have coefficients for our logarithms. It's going to be in our best interest to move those coefficients to be exponents for our arguments. Do that for the 2 and the 1/4. Simplify your arguments. 4 to the 4th is 16. The 4th root of 16 is 2. 2 times 2 times 2 times 2 is 16. Use the quotient property, which says if you're subtracting two logarithms with the same base, you can just divide your arguments. 16 divided by 2 is 8. Property of equality gives us x is 8. A very similar problem if we take our coefficients and write them as exponents for arguments. Simplify your arguments. 4 cubed is 64, 3 to the 4th is 81. Product rule. Adding two logarithms with the same base, you can multiply the arguments. 64 times 81 is 5,184. Property of equality says we get 5,184 equals x. Please note this should be a base of 7 written here, log base 7 of x. I can't change that right now, or I'm going to mess up this video. Number 23. Once again, we want to move our coefficients to be exponents for our arguments. Square root of 9, which is 9 to the 1/2, is 3. Cubed root of 27 is 3. Product rule, multiply your arguments. 3 times 3 is 9. Property of equality, x is 9. 24, look at the product rule. Adding three logarithms with the same base, we can multiply the arguments. X times x times x is x cubed. Property of equality, x cubed is 8. Cube root both sides, you get x is 2.